Hello everyone. In the previous chapter, we learned different conventional machining processes like drilling, turning, milling, and grinding, which all of them basically use a sharp cutting tool or abrasives to remove chips from the workpiece. In today's class, we will learn about the non-traditional machining, which refer to these other methods that remove materials by various techniques involving mechanical, electrochemical, thermal, and chemical, or combination between them, and they do not use a sharp cutting tool or abrasives in the conventional sense. The general non-traditional processes have been developed since the World War II in response to new and unusual machining requirements that could not be satisfied by the conventional methods. So why we need the non-traditional processes and why it is important? The first point is that we have some newly developed metals or non-metals with special properties that make them difficult or even impossible to machine using the conventional methods. Also, sometimes we have complex part geometries or unusual part geometries that it cannot be made using the conventional machining. And the third and last point is that if we need to avoid the surface damage that often happened when using the conventional machining, we can use the non-traditional processes. Again, we have four different classifications of the non-traditional processes. Mechanical, which use a high velocity stream of water or fluid, and abrasives, or sometimes both, as we will see now. We also have the electrical non-traditional processes, use the electrochemical energy to remove material, the thermal processes which use thermal energy to small portion of work surface and cause fusion or vaporized of that area. The last type of non-traditional processes is the chemicals, which use some types of chemicals that remove material from portion of work part while other portions are protected by a mask. So we will start with the mechanical energy processes, the first type of the non-traditional processes. Under that umbrella, we have five different types of processes. The ultrasonic, first one, then the water jet cutting, abrasive water jet cutting, which is basically both abrasives and water, abrasive jet machining, and abrasive flow machining. So the first one is the ultrasonic machining, which is a non-traditional machining process in which abrasives contained in a slurry are driven at high velocity against the workpiece and by a tool that vibrating at low amplitude and high frequency. So here we have high velocity of abrasives. We also have the tool that vibrating at low amplitude and high frequency. So this is the ultrasonic machining. You can notice the high frequency of the tool moving with a high speed, low amplitude and high frequency. And on another hand, we have the flow that have abrasives inside the slurry that moving in a high speed Now, the tool escalates in a direction perpendicular to the work surface and is fed slowly into the work so that the shape of the tool is formed in the part, as we can see here, the shape of the tool. However, it's the action of the abrasives that on the work that making the shape and not the tool itself. And this is the difference between what we learned previously in conventional processes and this ultrasonic machining. The applications of the ultrasonic machining: type of hard and brittle materials like ceramic, glass, and carbides. We also can use it for stainless steel and titanium, the non-rounded holes, and also the coining operations, which is a pattern on tool is imported to a flat work surface. The next type is the water jet cutting, where the water jet cutting uses a fine, high pressure, high velocity stream of water directed at the work surface to cut the work. You can see here, this is the water jet, and again the water should be at high pressure, high velocity, and it makes a small cut. This type of machining are usually automated, used for manipulate nozzles. It's also useful for cut narrow slits in a flat stock, such as a plastic texture or other types. It's not good for glass. The abrasive water jet cutting is similar to the water jet cutting, but we add abrasive particles, mix it with the steam of water. That abrasives could be aluminum oxide, silicon dioxide, or silicate minerals. Type number 4 is the abrasive jet machining. Now the difference between the water jet cutting, abrasive water jet cutting, and abrasive jet machining is that in abrasive jet machining, we use a mixture of gas and small abrasive particles. So instead of water, we have gas, and since it's an abrasive, so we have abrasive particles, same as the abrasive water cutting, but with the use of gas instead of water. It's gas containing small abrasive particles. You can see here is the workpiece. The abrasive or gas abrasive is steam, and that's the valve to control it. This type of operations usually performed manually by an operator and normally used as a finishing process rather than a cutting process. Applications like trimming, deburring, cleaning, and polishing. The work materials are thin, flat stock of hard, brittle materials, silicone, ceramics, glass, and so on. The last type of the mechanical energy processes is the abrasive flow machining. In abrasive flow machining, we have abrasive particles mixed in a viscoelastic polymer and forced to flow through and around the part surface and edges. So the difference here that we have abrasive particles mixed in viscoelastic polymer. The applications is deburring and polishing difficult to reach areas. The second type of non-traditional processes is the electromechanical machining processes. It's an important group of non-traditional processes that use electrical energy to remove material. This group is identified by a term electrochemical processes because the electrical energy is used in a combination with chemical reactions to accomplish material removal. Now, the thermal energy processes is material removal, non-traditional material removal processes that based on thermal energy, which characterized by very high local temperature that's hot enough to remove material by fusion or vaporization, or in some cases, both of them. That is the third type of non-traditional processes. Now, in some cases, the resulting surface finish is so poor, so subsequent processes is needed to make it better. Even though we have several types of thermal energy processes, in this course we will only focus on um, two types, the electric discharge machining and the laser beam machining. The electric discharge processes remove metal by a series of discrete electrical discharges or sparks that cause localized temperature high enough to melt or vaporize the metal of the part that need to be removed. Um, we have two main processes, the electric discharge machining and wire electric discharge machining. Now let us stop here and talk a little bit about lasers. Lasers are being used for a variety of industrial applications like the heat treatment, welding, cutting, drilling, and so on. The term laser stands for light amplification by stimulated emission of radiation. This is how the word laser comes from, and laser is an optical transducer that converts the electrical energy into a highly coherent light beam. So a laser light beam has several properties that distinguish it from all the other types or forms of light. It theoretically have single wavelength and highly collimated, which means that the light rays in the beam are almost perfectly parallel. These properties allow the light generated by a laser to be focused. Now, using the conventional optical lenses into a very small spot with resulting high power. Now, depending on the amount of energy contained in the light beam and the degree of the concentration at the spot, the various laser processes identified above can be accomplished. The using of beam of laser for as a non-traditional processes for machining by use of machine called laser beam machining, which uses the light energy from a laser to remove material by vaporizing that part of the workpiece. The types of lasers used in the laser beam machining are carbon dioxide gas lasers and solid-state lasers. This photo for a laser beam cutting operation that performed on a sheet metal. You can see the light, just the laser light. These some examples of products that produced using the laser beam machining. For example, this bicycle is only 20 millimeter or 0.8 inch long. Now let's go to the fourth type of non-traditional processes, which is the chemical machining. Material removal, where the chemical machining through contact with a strong chemical agent. So we use type of chemicals that could be used for milling, blanking, engraving, and photochemical machining. All use the same mechanism of the material removal, but for different purposes. These are the general steps for the chemical machining that regardless what type of chemical machining, we first do the cleaning or clean the workpiece to ensure the uniform etching, then masking or masking, which we apply it for to portion of work surfaces that we don't want to change, we do not want to etch it. Then the etching process can take place. So the exposed surfaces apply the chemical that attack those exposed surfaces, and after that we can do the demasking, which remove the maskant. The maskant is a protective coating, we call it maskant, that applied in certain portions of the part surfaces. Now the material could be different types of materials, polymers, neoprene, and as you can see. Now let's take for example the chemical milling. You can see that the first step is to clean the raw part. The next step is to apply maskant, which is, again, by the way, it is a protective coating. We call it maskant and is applied to certain portions of the part surface. This maskant is made of material that is chemically resistant to the etchant, which is the next step. So we apply the maskant, then scrape cotton peel maskant from area to be etched. So since we need the part removal to be in these areas, we remove the maskant from those areas that we want to expose them to the chemical, using several techniques: scrape, cut and peel. After that we can apply the chemical, which call it the etch. After applying the chemical, you can see how the chemical affect those exposed areas, and then the last step is to remove the maskant and clean the finished part. Main applications for the chemical milling is in large parts like the aircraft wings and fuselage, when we need to get rid of some materials to reduce the weight in case of the aircraft. I want to show you these three different products that produced using chemical blanking, and see how the chemical affect those, for example, areas that was exposed to the chemical to get these desired shapes. In general, these non-traditional processes can be applied to both metals and non-metals. However, certain processes are suited to certain work materials. Based on the process itself, different materials would be suited to certain processes. I want you to understand the difference between these four non-traditional machining that we cover today, which is again the mechanical energy machining, electrical chemical machining, thermal machining and thermal energy machining, and the chemical machining. Thank you for watching, and please let you know if you have any questions.